Hi y'all, today's session is gonna be a little bit different from the previous ones. I tried to do a virtual interview with a friend of mine. His name is Julian and he's from Cameroon. I asked him about 10 questions about data science and machine learning, and he did a video in machine learning in business. I hope you guys will like it. Please stay tuned. If you have any comment or doubt, please let me know in the comment section.
Hello, guys. I hope you are good. I am Julian. I'll be your host today. I'll be speaking to you about machine learning in business. So let me put my screen a bit up there. I'll be still available up there. So today I'll be again speaking about machine learning in business. I would like to thank Hayward for allowing me to speak to you through her YouTube channel about machine learning, data science, and artificial intelligence. Again, it will be a short one. All right. So let's go. Who am I? I am Julian, and I'm basically This is me here, and that's basically my LinkedIn profile. So I'm a software developer and a data scientist at working at Intellect. That's my base company. I have been deployed in a bank called Standard Bank in South Africa, where I do. I'm in a team where we do data engineering, software engineering, code optimization, reading a bit of machine learning code, and I'm also building some Python APIs, like pretty nice things to do. Also, my loose time part-time lecturer at the University of the Witwatersrand, where it's like I'm a part-time lecturer at the University of Witwatersrand, where I lecture basically introduction to computer programming using Python and C++. Um, the aim of that is basically to lecture or to teach about object orientation, memory allocation, garbage collection, and how all of those principles are working together. Data structures and algorithms, where we speak about normal computer science terms like stacks, queues, and sorting and things like that. Those are very important concepts that students need to know. And I'm also a PhD candidate researching about the importance or basically the use of binary neural networks instead of full neural networks, given that the binary neural network they carry less size compared to a normal integer when they are put in the network. So if you have a binary neural network against a full neural network, a binary neural network will have less weight than a full neural network that has floating points around the weights and the neurons. The problem is it doesn't have uh, that much flexibility as a floating number. You know, if you training your artificial neural network, you have maybe your weight at 0.5.66666, and then it can go down to 0.665, 0.64, and then 64 is the optimal solution that you can get for that network. But then a binary neural network, you just have a choice between some discrete values, and you can't have anything in between. So do we make the network longer, or do we make the network wider? So that's the question. Those are the questions that I'm trying to answer through my research. Good luck to myself. Okay. As you know, machine learning is that activity where basically the computer learns by experience, right? As you can see here, the experience is basically the data. The processing is a function that uses the data and a bit of noise so that we don't make the computer think that the world is perfect. And we have, at the end of the day, some predictions like what the machine learning was there for. It will be there for predictions. And these can be the data, it can be images, text, um, voice signal, and then some machine learning frameworks. We have TensorFlow, we have Keras, Scikit-learn, Gluon, MXNet, Theano. Like you see, all of those frameworks for you to do your machine learning. And then you have some predictions on the other side. Sorry, some questions that we want the machine learning model to answer. Will it rain? Is it a car? Um, Anything? Is the customer credible? So you have multiple use cases of where machine learning can be used. Now, we have this new field called data science, the one in the middle. And data science is just a mixture of a lot of fields, one of them being machine learning. But you are not meant to know all of this, but you are meant to know a couple of fields in here. Statistics, right? You need to know a bit of your statistics that will go through your normal distribution and your a bit of statistics and probability, how to take some sample of data, how to interpret that sample of data, how to sample out of some data, and how to do some analysis, some statistical analysis on the data, right? You need to be able to write some complicated, a bit of complication in your code, not to make your code complicated for free, but then you need to be able to write Python code so that your model can be used outside your Jupyter notebook. You need to have a bit of communication skills so that you can transfer your idea to the client, or you can receive the idea from the client. Those are communication skills that you need to understand, and also traditional research, right? Because as a data scientist, do not forget that you're also an academic in some point of view. So if a model is deprecated or there's a better model outside, then you need to go outside and do your research and take that new model and use it. Also, your database skills should be on point. That for sure. You need to make sure that you understand your databases well. All right. As a data scientist or as a data person, because as you can see on your left here, you have a lot of opportunities in data science, like data analyst, data engineer, data scientist, data architect. You have your statistician, your machine learning engineer. So yeah, you have those ones to do most of these activities. One of them is dashboarding. You have your normal Power BI, your Spark, your Hadoop, your Python. Okay, they all work under Python. And then you need to have a bit of cloud capabilities, which are your normal AWS or GCP, Google Cloud Platform, or Microsoft Azure. You need to understand those platforms so that your machine learning model can be hosted safely in the cloud. All right. So unfortunately, you have my image that will block velocity up there, but then here we're speaking about the velocity of the data, how the data travels from one side to the other. Then we either have real-time, batch, or stream of data, right? Whereas real-time and stream can be almost the same thing. We have the volume of data where the amount of data going from one stream to the other one, and the amount of data stored at a single place at a particular given time. And then we have the variety of the data that can be structured, unstructured, or semi-structured. We call them the three V's: variety, volume, and velocity. But then when we go ahead with that, you have the structured data that is your normal SQL, DB, your normal Postgres, DB, where you have your columns, right, and your rows. And a row will define all the columns, right? So this is very structured. You have an index, you have a schema, you have so many policies for your DB to work. The unstructured data, you basically have plain text, you have your tweets, you have your images, you have all of those structures that are not working with rows and columns like in the SQL way. And then you have your CSV or your JSONs that are semi-structured. So they do not have any schema enforcement, but then they some sort of audit, right? They do a bit of ordering in the way they keep the data in. Now let's assume that we have our whole data. Let's say we have a set of uh, JSON data that is of the size of some petabytes, and then it came in real time. It got stored into a DB. Now we have that those petabytes of data. It's like that's a discussion about big data. So big data, it's where again it's debatable. It's basically where all that data cannot be processed in a single computer. We need to basically use a cluster of computers to deal with those that big instance of the data. For this instance, I will use a South African bank called FNB. It can be any other bank. It can be I forgot the name of that bank. The Bank of Ethiopia, I guess. So let's assume that is any bank of in Ethiopia, and we're trying to understand what the people in Ethiopia are buying the most using their credit cards, right? So you can imagine how many users in Ethiopia, given a time t, are swiping their credit card to buy something, whether it's withdrawing money at the ATM or using their credit card at a retailer. How many of them in a single day use a credit card? That should be a lot in a day. After that, you would want to transform your data. So you want to make sure that your data is not at an explicit state where if someone steals it, it will compromise both the company and the user. And we wouldn't want to do that. So we want to make some columns. We want to remove some columns. We want to encrypt some columns. We want to mask some values so that we just get what we need to do with our model. And after that, we have two use cases that we can use in the data. So as you can see, we have on the lower left here some dashboards. It can be Power BI, it can be Tableau, it can be anything. But then that dashboard is basically telling you what is um, the current trend happening in the user space. What is the product that is mostly bought by the users? Where are the users buying them? How are they buying them? What is the volume of the way the users are buying most of those products? And after that, this is done mostly by the data analysts or statisticians, and then they can push basically their findings to the machine learning to the data scientists who basically write the models, and then those models will be then deployed by the machine learning engineers who will go through with that code, understand the code, and make it go through a production pipeline. All right. So here you would see on the left side of the screen, you have a lot of retailers. A lot of them are South African, and some of them are international, like Nando's. You have international Nando's, KFC, right? And then you have some other shops here that are plain South Africans, like Cambridge and Pick and Pay and Take a Lot. So let's assume that we would like to investigate the usage of the credit cards in all those shops during Christmas. Yes. So what usually happens is most of those users, yeah, right? They or most of those companies they can store the data in any format they want, and then they can store it in, like I said, in any format. It can be in Excel, it can be in JSON, it can be in SQL, Mongo, anything. Our job as data engineers is just to take that data and then aggregate it somewhere in a centralized place where the data is normalized. So we wouldn't care where the data is coming from. We just care about the data being at a single place. We can say KFC will have, we will make it structured or semi-structured, but we'll not leave it unstructured. So if we decide to go JSON, then we'll say KFC has these particular keys, Nando's has those particular keys, and the other shops they will have some different keys, or they will have rows and then they will have columns. And after that, um, we will be uh, either selling that data to the banks. These are the one of, I mean, like the big four banks in South Africa. uh, they are not the only ones. There are a couple more, but those are the main banks that we have here in South Africa, and they basically use all of that data to create new products and sell it to clients or produce it to clients so that they have a better life with banking. All right. This is all about banking, how to use that in the world and the world of economics and financial institutions. But then in Africa, how can we benefit from artificial intelligence? So you have a company in South Africa here called Air Robotics. They basically use some drones where they have embedded some computer vision techniques there to check the health of crops, right? You have the Masakane project. That's a very young project, but then it's growing pretty quick. Where in Africa we have a problem of language. As you know, English, the language I'm speaking right now, it's very broad currently. It's known by a lot of people in the world, and that's the language that we use to communicate across the world, right? But then, if I take in Ethiopia the Amharic language, which is a low resource language, we need to make it available to the world to understand. If you see Chinese, it's not a very easy language to deal with, but then because of the AI implementation in China, then we can now easily interact with China as we would interact with English and French and Portuguese and Spanish. So we're thinking about doing the very same thing with uh, languages like Amharic, Yoruba, um, Swahili, Sisit, Zulu. Sorry, I tried to say language here, but then I think I couldn't. Okay, and also, if you since we are done with Masakane, we now have an IBM project that basically tried to solve, not to solve, but then to bring a solution to the traffic problems we have in Nairobi, Kenya. So in Kenya, there is a lot of traffic happening there due to the bad state of the road. So this project headed up by Dr. Walcott, uh, it has an aim of working with the officials of Nairobi to make sure that we can fix the road using telematics and any other technique that would help us to fix that particular problem in that country or in that particular city, which is Nairobi. But then you have also some other examples about how AI can solve problems in Africa. As you can see, I'll spend a bit more time here because Africa is a growing continent. It's one of the oldest. It's the oldest continent, but then it's a growing continent because we have a lot of potentials in here. Like the language, for instance, we have a lot of languages that are not explicitly known or explicitly uh, taught or shown to the world, whereas the other languages are very well understood by us. So maybe AI through uh, maybe the Masakane project will help those languages to be discovered to the world so that when you go somewhere else, you speak their language and then you'll be easily understood while you keep your roots and your wherever you come from. Then you don't have to always try to keep foreign languages. I'm not saying that you shouldn't learn foreign language, just but our language as well are foreign to some others. But then our languages will be now better known outside. Also, regarding what we have in Africa in terms of our foods, our religions, our traditions, and our animals, everything we do, AI can help us to grow our knowledge or grow the knowledge of our continent to the whole world through computer vision, through image recognition, through um, language translation, so that we will be inserted into a bigger world dictionary of things, right? Like in the United States, like in Europe, where most of our data sets are coming from. Then we need to build also our own data set so that it can be merged to the broader world. That's basically how AI can contribute to the evolution of Africa. Why does someone have to be interested into AI or DS or ML? Because AI is a very hot topic today. Um, People tend to go to AI because it's very interesting. The deep fake where someone speak with someone else's face. So that's pretty cool. Um, And also, today you do not have to write complicated lines of code in this sense where in the past, if you needed to, for example, uh, I would like to describe this number as 9, so this is 9. But then if you had to write a computer program that would basically try to detect that 9, then it will be a lot of computer code to just detect 9 on the picture. But then today we have what we call convolutional neural networks that can go through your image and then detect the 9 from the experience of some other images. And then it'll be easier for you to just pick an API, plug it into your code, and say, detect a 9 in the image. Learning from example. And since 9 can be detected in the image here, then we can take that knowledge and submit it to a drone or a humanoid or a self-driving car to basically do those tasks automatically or autonomously uh, without the intervention of a human. But then we have to make sure that we give limits to those uh, machines so that they don't take over. Okay, they won't just take over because it's still limited in their thinking, but then we're going towards self-learning machines that can learn from previous experience and infer new situations from the previous experience they were having. Hopefully, we won't giving a mind and soul to a computer. And the community is forever growing. thanks to the deep learning in Daba that made this. Okay, the deep learning in Daba didn't contribute to this directly, but then the deep learning in Daba made me know Hewat and many other people in Ethiopia. So I held a lot of conferences around Africa, and one of which I have been in Ethiopia, Walaita Sodo University, where I basically talked about introduction to machine learning. So the the community is forever growing, and I saw a lot of nice minds that side, like PhD candidates and PhD holders in Ethiopia that are very serious about doing machine learning. So in Ethiopia, you are well sorted. You have a lot of nice people there who actually do correct machine learning mostly in natural language processing NLP. So through the deep learning lab and the deep learning lab X programs, it will be easier for you guys to get into the data science field. Whereas you shouldn't forget the most important part, which are uh, your computer science skills, data algorithms, data structures and algorithms. Sorry, uh, computer programming, statistics, probability, without actually going in depth there. But then you need to understand how it works. So um, that's basically me into this discussion. Again, I would like to thank you guys who watched this video towards the end. Again, I'm Julian. I was your host today. Hopefully, I'll be your host another time. And thank you very much, Hewitt. And hopefully, uh, uh, the AI community in your area and in Africa will keep on growing. Have a good day, afternoon, evening, depending on where you are. Cheers.